Good morning, student. I am N.V. Krishna Rao, Assistant Professor, CSC Department. So, in the previous classes, we have discussed the phases of a compiler and basics of the finite automata. We'll continue with the remaining concepts. Okay. So, regular expressions and finite automata. That is our discussion of the class. So, what is a language? Language is a set of alphabet, group of symbols from the alphabet is a string, rules and syntax rules of the grammar, plus operations on the languages. All these are combinedly results to the a language. Okay. Now, what is a regular expression? It is a declarative way of express the strings discovered by some language accepted by finite automata. Right? So, what is a regular expression? A language accepted by finite automata will refer as regular language. An expression to represent regular language is regular expression. Right? So, what is a language? A group of symbols, a sequence of symbols on some alphabet. If that language is accepted by some finite automata, then it is called as regular language. Then, any expression that is used to represent this language is called as regular expression. So, here sigma be any non-empty finite alphabet, then phi is the regular expression denoting the empty set language. Right? So, if we have non-empty finite alphabet, then if I is a regular expression denoting the empty set language, right? Then here the epsilon is a regular expression denoting a set containing only the empty string, right? Here this is for empty string and phi is for the empty language, right? Phi is for the empty set language. Epsilon is for the empty string. Then A is a regular expression for a set containing a language containing A. So these are the three basic rules of the regular expression by which we can construct a long, lengthy regular expression to represent any regular languages. So these are the main three properties. So these are called the primitive regular expressions, are building blocks of the regular expressions. One is for the empty set, another one is for empty string, another one is a set containing symbol A. Right? A is a regular expression for the symbol containing A. Then epsilon is a regular expression for the empty string. Phi is a regular expression to represent empty set. So these are the we refer as primitive regular expressions are building blocks. Okay. Then regular expressions. Here we have mainly three properties. Mainly we consider three properties: union, concatenation and clean closure. The previous three are primitive basic regular expressions. On that previous three regular expressions, on these previous three regular expressions, we apply these properties. What is these properties? Union, concatenation and closure properties. By combining these properties on these previous primitive regular expressions, we can construct any regular expression for any regular language. So the first one is union, right? A plus B is a regular expression. What is a regular expression? A plus B is a regular expression to denote a union of L of A and L of B. A plus B is a regular expression, right? A plus B, that we have to write for L of A union with L of B. Okay. Then A dot B is for the concatenation of two languages, right? It's a regular expression. A dot B is a regular expression which denoting the concatenation of two languages, LA followed by LB. Language of A and language of B. Is it clear? So union property, concatenation property. Then closure property, right? And the main one is closure property, right? This closure property says a regular expression, A star is a regular expression for language consisting the L of A, right? A star is a regular expression denoting the clean closure of L of A. That is L of E star is equal to L of E whole star. And also, if A is a regular expression, parenthesis of A also regular expression. If A is a regular expression, then parenthesis A also a regular expression. So the mainly three properties we use, that is union, concatenation and closure properties, right? The union is a union of two languages L of A and L of B. Concatenation, a concatenation of two languages L of A and L of B. Then clean closure, right, is a regular expression denoting the closure of L of A, right? And language accepted by A. A star is a clean closure. It is a regular expression denoting the closure of the language of A, right? So these are the three main basic properties, regular properties that we apply on the basic regular primitive regular expressions to construct a regular expression for any regular language, right? So here we are giving a relation between a regular expression, regular language and its explanation, right? So what are the main three properties? Empty set, empty expression, empty string, then a language containing symbol A. So these three are phi, epsilon and A. These are the main three basic primitive regular expressions. Phi means empty regular language, epsilon for a regular language for empty string, right? Empty language, right? Then A is a language containing A. A is a regular expression for language containing A. Now, A star. A star is a regular expression for containing the symbols epsilon, A, 2A's, 3A's and so on. Means that 0 or more occurrences of symbol A, right? What is A star? The closure of A. A star is a regular expression which states that 0 or more occurrences of the symbol A, right? Then A plus. Here A plus says that one or more occurrences of the A symbol. One or more occurrences of A symbols, right? That is the regular expression, that is A star. A star is regular expression, right? For positive closure, what it means? One or more occurrences of symbol A, right? Next, A union B. A union B is a regular expression for the language which consists the union of A and B, right? It's a union of A and B. Then A plus B star. A plus B star, it indicates that 0 or more occurrences of either A or B or both, right? It may have 0 occurrences, either only A or only B or two A's, AB, BA, two B's, three A's, and so on. Okay? Here, A plus B star is a regular expression, indicates that 0 or more occurrences of the A and B. So, 0 occurrence means epsilon, only A may occur, only B or A's and B's, any number of A's or any number of B's. Next, A plus B positive closure. A plus B plus sign is a regular expression. Here, this one is the regular expression for regular language. What is the regular language? Positive closure of A and B means that one or more occurrences of either A or B are both, right? It consists the all the strings on A or B which occur one or more occurrences of either A or B or the both. Next, here AB. AB is a regular expression for the regular language containing AB. Here A followed by B. Both should be contained. It's not like in either A or B. It's a string containing A and B, right? So this is a concatenation AB, right? Then AB star. AB star is a regular expression which consists 0 or more occurrences of AB. 0 and more occurrences of AB. Every time if present, it must be AB. Epsilon, single AB, two ABs, three ABs, and so on. Okay? It is a set of the strings such that 0 or more occurrences of AB symbol. Okay? Then A plus B star. A plus B star. It is a regular expression for language. It may contain A or 0 or more occurrences of B's. Right? A plus B star. A or 0 or more occurrences of B. Right? So that we have written as A plus B star. Then A plus B followed by AB star. What is this thing? The language strings all are start with either A or B, and second symbol must be A. The second symbol must be A. It follows by 0 or more number of B's. Here A plus B followed by AB star. It is a regular expression which says that all the strings of regular language must start with either A or B, and the second symbol must be A, and it followed by 0 or more number of B's. Right? Next, A star, B star. It is a regular expression which contains single B. All the strings will be consist single B. It is preceded or followed by 0 or more number of A's. 0 or more number of A's. It is preceded or followed by more number of A's. Right? That is A star, B, A star. Right? Then, here it is a regular expression which consists all the strings. It must be have at least one B. At least one B. What indicates that here star of the alphabet means A comma B star, then B, A comma B star. So 1B is must. It is preceded or followed by any number of A's or B's. In the previous only it is preceded or followed by any number of A's. But in this one, in this regular expression, it will be preceded or followed by any number of A's or B's. Right? Then, here, this is a regular expression which says that it might be empty string, or if it is consists a symbols, any number of 0 or more number of A's followed by 0 or more number of B's followed by 0 or more number of C's. But if exists, it must be in the order. If exists, it must be in order only. A's followed by B's, B's followed by C's. Order is must. But 0 or more occurrences of A, 0 or more occurrences of B, 0 or more occurrences of C. Right? Then, A star, B, A plus, B plus, C plus, which says that at least one symbol of each category should exist. One or more number of A's followed by one or more number of B's followed by one or more number of C's. A's, then B's, then C's. The order is must. One or more number of A's, then one or more number of B's, then one or more number of C's. Okay? So it is a regular expression which consists at least one of each symbol. Right? These we considered as a identity rules. These identity rules are used to simplify the large regular expressions to smaller regular expressions. Using these properties, these identity rules, we will simplify the regular expressions. We will simplify the regular expressions. Right? Concatenation of regular expression and 5 will result only with the 5. Concatenation of the empty strings with the regular expression will result the regular expression. A union of empty set and regular expression is regular expression. Union of the same regular expressions will be R1. Right? R1 union R2 equal to R2 union R1. Right? Here R1 concatenation with R2 union R3 can be simplified in this form. Here R1 union R2 concatenation with R3 we can simplify in this form, right? And R1 concatenation with parenthesis of R2 R3, concatenation of R1 R2 with R3 will be the same. Union of epsilon R1 closer is R1 closer. Epsilon union R1 concatenation with the epsilon union R1 closer nothing but R1 closer. The same here once again. Simply results R1 closer. R1 closer R2 union R2 is nothing but R1 closer R2. Concatenate in the empty set to any set yields to the empty set. Right? Concatenation of any empty set to with any regular expression will result to the empty set only. These are the identity rules which we use to simplify the large regular expressions to smaller regular expressions so that it can be used the remaining phases of the compiler design. Right? R1 closer or closer is nothing but R1 closer. Right? X is matches the character X. Dot matches with any character except new line. R star 0 or more occurrences of R. R plus 1 or more occurrences of R. Question mark 0 or 1 occurrences of R. Then matching the with beginning of the line. Matching with the ending of the line. Either R1 R2. Here it consists the symbols A, B, C. It's implement not. So these are the different meta characters or patterns in the regular expressions. So these are the different patterns that we use to write the regular expressions for the regular languages. Then rules for regular expression. Already we have seen what are the main three primitive basic rules, right? So epsilon is a regular expression for language containing the empty string, right? Then phi is the empty set, right? Then A is the regular expression for the set containing A. Then R and S are the two regular expressions for language L of R and L of S. Then we use three main properties. What are the three main properties? Union, concatenation, and closure properties. Right? We have seen in the previous slide that there we have used three main properties. What is union, concatenation, and closure? The union of two regular expressions is union of L of R union L of S. Concatenation L of R followed by L of S. R star is L of R closure. R is a regular expression denoting L of R. Right? So here if we have R and S two regular expressions denoting the languages L of R and L of S, then these are the four regular expressions to represent the union, concatenation, and closure properties. A regular definition gives names to certain regular expression and uses the names in the other regular expressions. Right? Regular definition. Here, regular definition is that we are giving a name to some regular expression such that we can use that name in another regular expression. Here, instead of writing a letters every time in regular expression, we use the letter. A regular definition letter which indicate either small letters A to Z are capital letters A to Z. A small letters A to Z are capital letters A to Z. Right? Then digits. Digit is a regular definition representing 0 to 9. All the numbers 0 to 9. Then a sign, either plus or minus. Sign either plus or minus. Okay? Regular expression for the identifiers. Identify letter R, letter digit star. Right? Letter R, digit star. Letter R, digit star. Okay? A regular expression for the identifiers. Letter R, digit star. Okay? Then regular expression for the decimals. 0 or 1 occurrence of the sign or 1 or more number of digits. What is an identifier? Identifier says that a letter followed by letter 0 or more occurrences of letter digit. So letter followed by 0 or more occurrences of letter digit. Then what is a decimal? Decimal is 0 or 1 occurrence of sign followed by 1 or more number of digits. 0 or 1 occurrence of sign followed by 1 or more occurrences of the digit. Right? Then only for digits. Digits equal to digits followed by 0 or more occurrences of the digits. Then what is a number? Number may have digits, optional fractional part, optional exponent part. Is the optional exponent part. It's a optional fractional part. Right? And simply digits. A number might be a simply digits sequence of numbers. Or it may be followed by optional fractional part. Okay? Or it might be followed by optional exponent. Right? So for today, I'm closing this section, discussing the regular expressions, writing the regular expression, representing the regular expression. So in the next class, we'll discuss how to represent regular expressions for the tokens of the programming language. So we knows that tokens might be identifiers, numbers, or it might be keywords. So operators. So we'll discuss how to write a regular expression for the different tokens of the programming language. So for this section, I am closing. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.